If you have ever installed Linux on an old laptop and felt like you brought it back from the dead, you are not alone. Many people have had the same experience. A machine that struggled to open a web browser on Windows suddenly feels responsive again. Boot times shrink. Applications launch faster. The system feels lighter, smoother, less burdened. This experience often leads to the same question. Why does Linux feel faster than Windows on old hardware? To answer that properly, you have to look beyond simple benchmarks. The difference is not magic. It is not because Linux is automatically better in every technical sense. It comes down to design philosophy, system requirements, background services, memory management, modularity, and the way each operating system evolves over time. When hardware ages, those differences become more obvious. One of the most immediate factors is system resource usage. Modern versions of Windows are built with contemporary hardware in mind. They assume you have several gigabytes of RAM, a fast multi-core processor, and solid-state storage. As Windows evolves, new features are layered on top of the old ones. Visual effects, security frameworks, telemetry systems, indexing services, background updates, and compatibility layers accumulate. Each of these components consumes memory and CPU cycles, even when you are not actively using them. On an older system with limited RAM, that overhead matters. If you only have 2 or 4 gigabytes of memory, the operating system itself can occupy a significant portion before you even open an application. Once memory fills up, the system starts relying heavily on swap space or paging files, which use disk storage as temporary memory. On older machines with mechanical hard drives, disk access is slow. When the system constantly swaps memory pages in and out of disk, everything feels sluggish. Linux distributions, particularly lightweight ones, often have much lower baseline resource usage. A minimal Linux desktop environment can idle at a fraction of the memory footprint of a modern Windows installation. There are distributions designed specifically for low-resource systems, using desktop environments like LXQT, XFCE, or even lightweight window managers such as OpenBox or i3. These environments avoid heavy animations, large background services, and complex graphical frameworks. As a result, more of the system's limited memory remains available for applications. Another key factor is modularity. Linux is built in layers that can be included or excluded depending on need. You can install a minimal base system without unnecessary components. If you do not need Bluetooth support, you can disable it. If you do not use printing services, you can remove them. If you want a simpler display manager or none at all, that is an option. This modular approach allows Linux to scale down gracefully. Windows, in contrast, is more monolithic from a user perspective. Many components are tightly integrated. Even if you never use certain features, they often remain installed and active in some capacity. Over time, this contributes to baseline overhead that cannot easily be removed. On powerful modern systems, that overhead is negligible. On aging hardware, it becomes noticeable. Background processes play a major role in perceived speed. A fresh Windows installation runs numerous services by default. These include update services, security scanning tools, telemetry collectors, cloud synchronization services, indexing for search, compatibility services, and more. Each one may only use a small amount of CPU or memory individually, but collectively they create constant background activity. Older CPUs, especially those with fewer cores or lower clock speeds, struggle more with multitasking. If background services are constantly waking the processor to perform tasks, the CPU has less availability for the application you are actively using. This can manifest as input lag, slower application launches, or momentary freezes. Linux systems, particularly lightweight setups, typically run fewer background services by default. Many distributions prioritize simplicity. While there are still essential daemons for networking, logging, and scheduling, the overall number is often smaller. Additionally, Linux gives users straightforward tools to inspect and disable services. Systemd, for example, allows administrators to see exactly which services start at boot and to disable those they do not need. This transparency helps users tailor performance. File system behavior also contributes to the difference. Windows primarily uses NTFS, which is robust and feature-rich but carries certain overhead. Linux distributions commonly use file systems such as ext4, which are optimized for performance and stability in Unix-like environments. While NTFS is not inherently slow, Linux file systems can feel more responsive under certain workloads, especially on older mechanical drives. Another subtle but important factor is fragmentation and long-term system bloat. Over years of use, Windows installations can accumulate registry entries, leftover files from uninstalled programs, and various background tasks added by third-party software. While modern Windows versions manage this better than older ones did, the system can still become cluttered over time. Startup entries multiply. Context menu integrations expand. Scheduled tasks accumulate. Linux systems, particularly those managed through centralized package managers, tend to avoid this type of gradual bloat. Software installed through a package manager is tracked cleanly. When removed, it often leaves fewer remnants. Configuration files may remain by design, but they are usually small text files, not complex registry trees. The absence of a centralized binary registry database reduces the risk of systemic slowdowns tied to registry growth or corruption. Perceived speed is also heavily influenced by the desktop environment. Windows uses a consistent graphical shell with animations, transparency effects, and integrated features. Even if these effects are subtle, they require GPU acceleration and system resources. On older machines with weak integrated graphics, rendering these effects can cause lag. Linux gives users a choice. You can run a full-featured desktop like GNOME or KDE Plasma, which are visually rich and comparable to Windows in complexity. But you can also choose minimal environments that use fewer graphical effects. Some window managers barely use any animation at all. When the graphical layer is lightweight, the system responds more quickly to input, especially on hardware without strong GPU support. Boot time is another area where differences become obvious. Windows performs numerous checks and starts multiple services during boot. It may also apply updates in the background or verify system integrity. On an older hard drive, each of these steps adds delay. Linux distributions can boot extremely quickly, particularly when configured minimally. With fewer services to initialize and less background processing, the system reaches a usable state faster. Security architecture contributes as well. Windows has historically been a primary target for malware, which has influenced its design. Modern Windows includes extensive built-in security mechanisms, real-time antivirus scanning, secure boot integration, driver signature enforcement, and various exploit mitigation technologies. These features are important for protecting mainstream users, but they also consume resources. Linux is not immune to security concerns, but its typical usage patterns differ. Many Linux users install software exclusively from trusted repositories, rather than downloading executables from random websites. This reduces the need for aggressive real-time scanning of every file operation. As a result, the system may perform fewer constant background checks on file access, reducing overhead on slower drives. Driver architecture can also impact performance. Windows must support an enormous range of hardware from countless manufacturers. To maintain compatibility, it includes generic drivers and complex driver frameworks. On older systems, outdated or poorly optimized drivers can slow performance. Linux, while also supporting a vast range of hardware, often benefits from open-source drivers integrated directly into the kernel. These drivers are maintained alongside the kernel itself, sometimes resulting in efficient, streamlined performance for older hardware. Another factor is update strategy. Windows updates can be large, frequent, and sometimes intrusive. On older hardware, background downloading and installation of updates can noticeably slow the system. Disk usage spikes. CPU usage increases. Occasionally, the system may schedule update tasks at inconvenient times. Many Linux distributions also update frequently, especially rolling release ones, but the process is often more transparent and under user control. Updates typically occur when the user initiates them. They do not usually involve heavy background processes running continuously. On low-resource systems, that difference in update behavior can affect perceived responsiveness. Memory management strategies differ as well. The Linux kernel has long been praised for its efficient memory handling. It aggressively uses available RAM for disk catching to improve performance, but it can release that memory quickly when applications need it. This flexibility can make the system feel snappy, even when RAM is limited. When memory pressure increases, Linux may handle swapping differently depending on configuration, sometimes resulting in smoother degradation under load compared to certain Windows setups on identical hardware. Application ecosystems also influence the experience. Many Linux users choose lightweight applications that match their system philosophy. Instead of heavy office suites, they might use simpler editors. Instead of feature-packed media players, they might choose minimal ones. Windows users, by contrast, often install large, resource-intensive applications designed with modern hardware assumptions. When you pair a heavy application ecosystem with an already resource-hungry operating system, older hardware struggles. Another reason Linux feels faster is the absence of aggressive vendor pre-installation. Many Windows machines, especially older consumer laptops, come with preloaded software from manufacturers. Trial antivirus programs, promotional utilities, system monitors, custom control panels, and background updaters can all run at startup. This bloatware consumes memory and CPU from day one. Even if the hardware was adequate when new, years of accumulated background programs can slow it down dramatically. When you install Linux on that same machine, you often start with a clean slate, no trial software, no manufacturer utilities, just the base operating system and the applications you choose. This alone can transform the user experience. It is not that Linux is magically faster. It is that it avoids the ecosystem of bundled extras that weigh down many Windows installations. Storage differences amplify everything. Many older machines use traditional spinning hard drives. These drives are significantly slower than modern SSDs, especially for random read and write operations. Windows performs numerous background disk accesses for indexing, login, telemetry updates, and antivirus scanning. On a mechanical drive, these operations can create noticeable lag. A lightweight Linux installation may perform fewer constant disk operations. With less background activity, the drive is free to focus on the task you initiated. Applications open faster, not necessarily because they are inherently lighter, but because the disk is not simultaneously servicing multiple background requests. It is also important to consider the lifecycle expectations of each system. Windows is designed to maintain backward compatibility across decades of software. This means carrying forward legacy subsystems and APIs. Supporting old enterprise applications is a priority. This commitment to compatibility increases complexity. Complexity increases resource usage. Linux distributions, while also supporting legacy software in many cases, do not carry the same commercial compatibility burden. They can remove outdated components more freely. They can adopt new technologies without preserving every historical interface. This flexibility allows some distributions to remain lean over time. There is also the psychological component of perceived speed. A responsive interface with minimal animation and immediate feedback feels faster, even if raw processing power is unchanged. Lightweight Linux desktops often provide immediate visual response to clicks and keystrokes. Windows, with its layered graphical shell and background tasks, may occasionally delay response by fractions of a second. Those small delays accumulate in the user's perception. Power management can also differ. Some Linux distributions are optimized to use fewer background CPU wake-ups, allowing the processor to stay in low-power states more consistently. On older laptops, this can reduce heat and thermal throttling. If a system overheats, the CPU may reduce its clock speed to cool down, resulting in slower performance. By running lighter workloads, Linux may indirectly avoid such throttling, maintaining steadier responsiveness. Another overlooked aspect is customization of kernel and system components. Advanced Linux users can compile custom kernels optimized for their specific hardware, removing unnecessary drivers and features. While this is not common for casual users, it demonstrates the extent to which Linux can be tailored to limited systems. Windows does not offer comparable customization at the kernel level to end users. Even at the process scheduling level, Linux and Windows have different approaches. The Linux Completely Fair Scheduler is designed to allocate CPU time efficiently among processes. Under certain workloads, particularly with fewer background services competing, applications may receive more consistent CPU slices. On a lightly loaded Linux system, foreground tasks often feel prioritized simply because there is less contention overall. It is worth acknowledging that Linux does not automatically outperform Windows in every scenario on old hardware. If you install a heavy Linux desktop environment with numerous startup services, the difference may shrink. If Windows is freshly installed without bloatware and with unnecessary services disabled, it can perform reasonably well. The comparison often depends on configuration choices. However, Linux offers more flexibility to scale downward. That flexibility is the core reason it feels faster on aging machines. It can be stripped to essentials. It can run with minimal graphical overhead. It can avoid unnecessary services. It can operate comfortably within tight memory constraints. In many ways, Linux distributions designed for low-resource systems are closer to the computing realities of older hardware. They do not assume constant high-speed internet. They do not assume terabytes of storage. They do not assume abundant RAM. They are comfortable operating within limits. Windows, by contrast, evolves alongside modern hardware trends. As average system specifications rise, Windows adapts to take advantage of them. New features demand more memory. Security systems grow more sophisticated. Visual interfaces become richer. These improvements benefit users with contemporary machines. But they leave older hardware behind more quickly. The feeling of speed, then, is not just about raw efficiency. It is about alignment. Linux can align itself with the constraints of old hardware more easily than Windows can. When an operating system's expectations match the machine's capabilities, the experience feels smooth. When the expectations exceed the capabilities, the experience feels strained. For someone reviving a decade-old laptop with limited RAM and a slow hard drive, installing a lightweight Linux distribution often removes layers of accumulated overhead. It replaces a system built for modern hardware assumptions with one that respects minimalism and modularity. The result is not magic. It is simply a better match between software demands and hardware capacity. Ultimately, Linux feels faster than Windows on old hardware because it can be lighter, more modular, less burdened by background services, and more adaptable to limited resources. It offers environments that prioritize efficiency over visual complexity. It allows users to remove what they do not need. It avoids much of the pre-installed software and persistent background activity common in mainstream Windows installations. Old hardware struggles not because it is incapable of computing tasks, but because modern operating systems often demand more than it was designed to deliver. When you reduce those demands, the hardware can breathe again. Linux, especially in its lightweight forms, excels at reducing those demands. That is why an aging laptop can feel reborn under Linux. Not because the hardware changed, but because the software finally fits.